Okay, good morning class. So today we're looking at Euclidean Geometry, exercise 3 number 5. Right, so we are told that in triangle ABC, PQ is parallel. So PQ is parallel to MN, which is parallel to BC. Then we are told that CA is twice NA. Okay, so from there we can conclude, which is 4 times QA. But QA was marked X, not so. So if QA is marked X, QA is X, but CA is 4 times X. Can you see that, people? CA is 4 times QA. QA is X, so CA is going to be 4x. So that's given to us, yes. But CA is twice NA. So what is CA? 4x is equal to twice NA. So NA is equal to 2x. So if NA is 2x, if NA is 2x, then what is QA? 2x minus x, which is x. Not so? Then what is NC? Also 2x. So without going any further, what do we know? Parallel midpoint. So that length is equal to this length. These lines are parallel. Sorry, these lines are parallel. That is the midpoint. 2x and 2x. So AN is equal to MB. Midpoint theorem. Or converse theorem. Okay. Oops. First question. A. Prove that AN is equal to NC. AN. Oh my word. So okay. So let's do it. We firstly, the first thing that. So that's going to be your first step. And then NC is going to be NC is equal to AC minus AN, which is 4x minus 2x, which is 2x. Okay, I don't know how they expect you to write this out, as there's no reason, no Euclidean reason here. Otherwise, you could have written here in the side QN is going to be AN minus A2 if you wanted. Okay, but there's not the format they give it to you in. Okay. But everything asked here, I really got in the time. Let's look at B. B says calculate PQ. Calculate PQ. This line here. If BC is 32. So if BC is 32, we know that in M is 60. It's half of that, not so. We already said that that's the midpoint. As you can see, that's 2x and 2x. So that's going to be half, so that's going to be 16. And there's also the midpoint. Right? And these lines are parallel. So if this is 16, then it's going to be 8. But of course, we have to lay it out. Okay, so we say in triangle. We start the big triangle, which is A. In triangle A, B, C. Alright, so we know that. I'm going with the story here. Huh? So we know that AN is equal to NC. Now, where did we get that from? Was it given to us? Proven. We'll just proven that. Okay. That is proven. And then we know that NM is parallel to BCY given. So therefore, Mn is going to be half of 32. Why could I visit it in 16? Why? Converse of midpoint theorem. Okay. So here's 16 now. So in this triangle here, that's again the midpoint. Okay? So in triangle, A in, or A in, M in, whatever. What do we know? We know that AQ is equal to QN. Why? Given. Not given. Proven. Okay. What else do we know? We know that PQ is parallel to MN. Why? Given. So therefore, PQ is going to be half of 16, which is 8 centimeters. Why? Converse of the midpoint here. The converse of the midpoint here. Okay? Easy enough? You'll see somebody else do it. Right, let's do number 6. It's also exercise 3. This is on page 258. Okay. So we are told that triangle PQT is inscribed. People, what does that inscribe mean? It's in the circle with the vertices PQR touching circumference of the circle. Okay, PQT. Then we are told that OA is parallel to QR. OA is parallel to QR. Okay. Then we are told that AP is equal to AQ. So what do we know from there? We know that PO is equal to OR. But we know that. That could have been our midpoint theorem, but why else is OP equal to OR? I can tell you the radius, okay? No, wait for you still. So, and BP is equal to BT. Okay. Now you see that is, remember that is also equal to this. So these lines are actually parallel. Can you see that, people? Right. First question. Prove that AB is parallel to QT. Very simple. The midpoint theorem is shouting at us here. Not so. So we say A. In triangle PQT. What can we say in this big triangle? What do we say? We can say that AP is equal to AQ. Why? Given. PB is equal to PTY. Given. Therefore, those lines has to be parallel. Why? Midpoint theorem. Okay. So, AP is equal to AQ. Given. Then PB is equal to BT. Why? Given. Therefore, AB is parallel to QT. Why? Midpoint here. Okay, so I'm going to pull that now. Okay. Any confusion there? Can't believe it's so easy, huh? Let's look at question B. Oh. But prove that O is the center of the circle. I just assumed it was the center of the circle. You see what I did earlier? My mistake, no? You could have just have said that PO is equal to OR. Why not? They didn't tell us O is the center of the circle. Okay, my mistake there. Because now they want you to prove that O is the center of the circle. If PR is the diameter. Okay. So how do we prove this is the center, people? If we can prove that PO is equal to, but be in this triangle, in triangle PQR, in this triangle, what can we say? That is equal. These lines are parallel, that one and that one, not so. So that has to be equal. Why? Converse of midpoint. Okay. So in that triangle, we know that PA is equal to QA. Why? Given or proven? What doesn't matter at this stage, because they mentioned before. Did I have to mention it now again? No. Then AO is parallel to QR. Why? Given. Therefore, PO is equal to OR. Why? Converse of midpoint here. Okay. So that is now, of course, the center. So therefore, O is the center of circle. Okay, or you can say that since PR is the diameter and PO is equal to OR, therefore O has to be the center of the diameter. Or OP is your radius, or whatever you wanted to say. All would be acceptable. You want to take off? Okay. Next question says that prove that BORT is a trapezoid with trapezium. BORT. People, what is the properties of a trapezium? Sorry? Yes, the one property is that it has a set of parallel lines, opposite sides are parallel. Not so. So if we can prove that OP is parallel to RT, I've done the job. Not so. So let's go. We know that PO is equal to OR. Why? Proven, not given. Proven. Then PB is equal to BTY, given. So therefore OB is parallel and so on. Why? Midpoint here. Okay. That line is parallel to that line. So, since that is the case, since those lines are parallel, therefore, BORT is a trapezium. Why? Because it has one pair of opposite sides. Okay, you guys understand? Easy. 7. Number 7, we are told that O is the center of the circle. These any point circumference AD produces only. What does that mean? AD produces only. Lisa Khan is closing her mouth in surprise. Not because she's tired and yawning, yes? Yes, Maja, what does that mean? Your hand was up? Not up anymore. People, anybody, what does that mean? When they say that AD produced its own length. The length of AD, its own length, so that length has to be the same as this length. So produce its own length. Whatever AD was, if it's extended in its own length, BD will be. You understand? So I'm going to mark this here. Now I'm going to write it down before I forget. So BD is equal to DA. Why? Given that it produces its own length. You can write given that AD produced its own. That's all. I don't even think you need to write that reasoning. Okay, but it's the first time you're coming across that, so you don't need to highlight that again. AD produces its own lengths to B. Prove that CAB, angle CAB, which is this angle, is equal to CBA. So how do you think we're going to prove that? OC, yes? They say that OC, your radius is x, no? So if that is x, this will be x, yes? That is 2x. This is a tangent here. Huh? Sorry? Doesn't say so. So we can't assume that. This is 0. So this is it a question with regards to this? Nope. That's the only question. What if I join this here? Yes. Huh? Then this will be parallel. So how is that going to help us? So this is x, this is going to be 2x. X plus x also 2x. You see, we can have a go far together. So did you guys see it? This was a very nice question. So let's go. We're going to construct construction OD, radii OD. From there we know that, therefore, AO is equal to OC, which is equal to OD, which is equal to X. So I'm putting all my X's here, no? Right. Now what can we say? In triangle ACB, the big triangle. What do we know? We know that OA is equal to OC, which is equal to X. Why? Proven. Did I have to write this here? No, because that's still part of one sum. Okay? No, you don't have to write this. I think I should have just let it out. But anyway, then we know that OD is equal to BD. AD is equal to BD. Why? Given that was given to us. No? Then we know that OD is parallel to CB. Why are these lines? Do we need to know that? And can we say that is equal? We don't need that, no, to be parallel. We needed CB to be 2x. So we're saying that CB is equal to twice OD, which is equal to 2x. Why? Why is that the case? Because the midpoint theorem. Midpoint theorem. So what do we notice now? That is 2x and this is 2x. Not so. Therefore, angle A, which they call CAB, has to be equal to angle B, which they call CBA. Could I have just called that angle A and angle B? Yes. Okay. And why is that the case? Because it's sides. No. Yeah, angles opposite. Why am I getting confusion? It's angles opposite equal side. The sides are equal, therefore those angles has to be equal. Do you guys understand? A nice question, eh? You didn't come across one of this before? And the last one. Not all for our lives, no? Look at so exercise 3. Okay. Okay, so we are told that intra-angle PQR. Intra-angle PQR. So PQR. We are told that A is a point on PQ such that PA is to AQ as 5 is to 4. So you can say it as PA over AQ is equal to 5 over 4. So I'm going to put here 5K and 5K and 4K. Then we are told that B is a point on PR such that BB is, now I can't just use K again, 5 is to 2, so I use 5A and 2A. AB produce cuts QR at T. So P AB produce, you see, it's not saying produce its own length, it's just say produce, which means to say extended to meet that QR at T. And S is the midpoint. S is the midpoint, so that length is equal to that length there. You all see that? S is the midpoint of AQ. S is the midpoint of AQ, yes. Prove that AT is twice SR. So AT must prove that AT is twice SR. So people in this triangle here, if I can prove that this line is equal to that line, or I can prove that that line is parallel to that line, the job is done. Not so. Because if these two lengths are equal, midpoint theorem will be the case that that is true. Or if those lines are parallel, the converse of the midpoint theorem will make that case true. Why? Because we have two lengths and the parallel lines. Okay, so either or. But it's not going to be so easy. Okay? For these lines to be parallel, we look here. To prove that these lines are parallel, I think it's going to be the easier one of the two. Because if we can say that PA over QA is equal to PB over, you see that is going to be, no, there's a parallel line. So we can prove that PS over SA is equal to PB over BR, which is 5K over 2K. is equal to 5a over 2a. Can you see that, people? So the ratios are equal. This is coming from exercise 2, the converse of the proportionality theorem. Okay? I feel the same way. Right, so let's just wrap this up quickly. I don't have to do this again in the next lesson. So firstly, we're going to say that AS is equal to SQ, which is equal to 2K. Why is that 2K? Because it is given S to be the midpoint. It was given here something that S is the midpoint. Then we're saying that, sorry, this is now in triangle PQ, PSR. What can we say? We're going to say that PA over AS is equal to 5K over 2K, which is 5 over 2. Then we're saying that PB over BR is equal to 5A over 2A, which is 5 over 2. So hang on, since PA over AS is equal to PB over BR is equal to 5 over 2. Since that's the case, below this goes, therefore AB is parallel to SR. And why is that parallel? Because converse of the proportionality theorem, or line divides triangle PSR in proportion. So those lines are parallel.
Zintless Baker, can you please report to the office?
I need that.
Baker, please
now,
report
of course,
to
for
the
the
office.
next part of the calculation, as I need the space here. Sorry about this now. So, what do we notice now? In this triangle, what can we say? In triangle AQT. This triangle here. That triangle, we're going to say that SQ is equal to SA. Okay? Again, we don't have to say this because I've mentioned it before. Okay? Then SR is parallel to AT. That's also proven. Okay? So therefore, AT has to be equal to double SR. Why? Because that's the converse of the midpoint theorem. Okay, and then the last question. You must prove that. I'm going to take this off here. As we now know that the midpoint theorem is evident there. We are told that if RK is parallel to QX, determine PX is to Q3. Okay, I'm going to do it in the next lesson, the other class, and on to at your teacher's scale. So you guys can leave, you can just watch the video for the last part, okay? Okay, coming back to this here.
My apologies for this interruption. Ms. Dixon, can you please communicate with the office? Ms. M. Dixon, please buzz the office.
Okay, so the question says if RK is parallel, RK is parallel to QX, RK is parallel to QX, so that whole industry is. Okay. Determine PX, so PX which is this length here, is to XT, which is this length here. Okay. Take this page here, Michael. As soon as you're done, you drop it on my table and you can leave, okay? So write on. Let's take out your maths book. Will somebody give her a page, please? Okay. Okay, so if we look at the lines that is given parallel, okay, according to this triangle highlighted in green, which is coming from the previous question, we know that XR is equal to RT. Why is that the case? Because of the midpoint theorem here, the converse of the midpoint theorem. So we're going to say that QR, let's first, we're going to first say that the QR is equal to RT, the converse of the midpoint theorem. Converse of the midpoint theorem. Okay? You remember now that QS is equal to SA, so is QR equal to RT. Now looking at this triangle here, I'm just going to highlight this triangle for you here. We can now say that, I'm missing this up here. Yes, that was it, right? So, need to stand back because this diagram is overpopulated. But what I was going on to now prove is that in this triangle, in triangle QXT, we can now say that XK, we're going to first say that QX is parallel to KR. And why is that the case? That was given to us. Okay? So is QR, that is the converse of the midpoint theorem. So therefore XK has to be equal to KT. So this line here is also equal. Why? Because of the converse of the midpoint theorem. Now the converse of the midpoint theorem. But how is that going to help us? Okay. I just need the space, so I'm taking this off, not because it's wrong. Okay, so what I say now is that you see this line is equal to this line. But in triangle P or K, in that triangle, in triangle P or K, we know that that line is parallel, so we see that already. So PR, let's check here, PB, so PB over BR is equal to PX over XK, okay, which is equal to 5A over 2A, which is 5 over 2. The reason there, why is PB over BR equal PX over XK? Because of the prop theorem, the proportionality theorem, with BX being parallel to RK. Okay, so the sum of 4 is going to be 5x, and this is going to be 2x. But we know that xk is equal to kt, which is equal to 2x. Okay, because they are given proven equal. Okay, that's also 2x. So now we can do what they asked us. So therefore, px over xt is going to be 5x over 2x plus 2x is 4x. We're giving the answer 5 over 4. But to give it in the, this is now number 8, okay? To give it to you in the ratio that they wanted, Therefore, Px is to xt as 5:2. So that basically brings us to the end of exercise 3. The full lessons can be found in the description box below.